Okay, welcome to your first assessment in terms of concurrency. So what I want to do, I want to write a program, a concurrent program, and then I want to show you the problem that this concurrent program has. And then I want you, your responsibility is to use one of the concepts, one of the tools that we have studied to fix this program. Okay, so the scenario is we want to um, play a buzzing game, like a talk show game where um, you have two people, you have two buzzers, and a question is asked, and whoever hits the buzzer first gets to answer the question. Okay, all right. So let's implement this buzzer game. Okay. Okay, so package main, I'm gonna do a few imports. Uh, the concept is it's a very simple game. Okay, we will just implement two Go routines. Okay, we'll need the time library package. Okay, and we'll need the mat.rand package. Okay, so let's create two channels. I could call it ch1, and we will make it string. Okay, ch2, and we'll make it also a string. Okay, so remember, you can think of channels as pointers. Well, actually, they are implemented as pointers. Okay, um, but we call them channel so that we abstract the idea that, oh, it's a pointer that you can put in data, right? We don't need to talk about that. We just call it a channel, and that makes it easier to work with. Okay, so we create two channels for the players. Okay, for the two players. Okay, great. And so now, since each player there is a equal probability, right? There's a 50-50 chance that either one of them can hit the buzzer first. So since that's the case, we know that this can't be a sequential program. So we will create two Go routines. So each player, right, is represented by a Go routine, right? Since we are making this a concurrent program, right? It's a concurrent process where one person or both people have the same chance of hitting the buzzer. Okay, so let's create an anonymous Go routine, right? And so what we need to do to make it kind of fair, we will make each Go routine sleep randomly. Okay, and so by doing this, I want to demonstrate to you that it could be I'm simulating what would happen if player 1 hits the buzzer first, or what would happen if player 2 hits the buzzer first. Okay, and so I'm going to use a random number generator. And so, as if you recall from your C++ programming class, you have to create a seed, okay, which is just a number which we will apply to the random generator so that the number that comes out from it is truly random. Okay, and so to get that number, I'm just going to use the this function. Okay? This function returns an int 64. Okay, and so seed expects an int 64. So we will say time.now. What is the time now? And then we will simply use Unix Nano, which takes January the 1st, 1970, and then it looks at the time now, okay, and then it finds out how many seconds has elapsed, has gone between those two dates, okay, and that integer is what we will use for seed, okay. Okay, so now once we have seeded our random number generator, we will now use it, okay, and so we will let the Go routine sleep, okay, for a random time, and so we're going to say time that duration, okay. Remember, sleep needs a duration, a time, and so we're going to say time that duration, and we're going to take the random number generator, okay, right, rand int, and so rand that int expects an integer and it returns an integer, right? A number, a random number between 0 and whatever you enter. So if I enter 500, then it's going to return a number from 0 up to 499. Because if you notice from your algebra class, it has a open interval, a parenthesis. Okay, and remember from your algebra class, whenever you see that, it means the last number is not included. When you have a square bracket, it means the number is included. So it returns a number from 0 to 499. Okay, and then whatever is returned, I'm going to add 500 to that. Okay, and then to make it a little bit more random, I'm going to multiply whatever I get by a millisecond. Okay, a millisecond. That should be enough. And so this Go routine will sleep for this much time. Okay, this much milliseconds. Right, this much milliseconds. Okay. Now, after the Go routine wakes up, we will have the Go routine write to channel 1, players 1 buzzer. Okay, signifying that player 1 hit the buzzer. And then we'll create another Go routine for player 2. So I'm going to copy and paste since I don't want to rewrite all of this code since it's similar. Right? And so, right, this is for player 2. And we'll sleep for some random time. Again, because we're randomly generating an integer, the sleep time for this first Go routine will be different than the sleep time for this Go routine. Okay. Now, when we have our Go routine waking up, we will say that it will write to channel 2, players 2 buzzer. Okay, so of course, it's a Go routine. If it's an anonymous Go routine, I need to use my parentheses. Okay. Good. Okay. So after I have done that, I will now read from the channels. Okay, and so let's read from the players. Okay, and so I can simply say fmt dot print line. I'm going to read from channel 1, and I'm going to read from channel 2. Okay. Okay. All right. So why is it giving me a red mark? Am I missing something? Let's see. I don't see any problem, but let's give it a run. Oops. Go run. Buzz. I named my file Buzz. Okay. Okay. Okay, it says expression on line 14. Okay. That's interesting. So if it's telling me about line 14, I'm guessing the problem is somewhere up above that. Okay, channel 1, channel 2. I'm writing to channel 1. Okay. I see the problem. Wait a minute. Okay. I have 3 of them. That's my problem. It should be 2. Alright, so why do I have this extra one here? Anyway, that's when you copy and paste. It always happens. Alright, so yeah, 1, 2. Okay. Alright, and so they always that's the reason why they tell you don't copy and paste, because it always comes back to bite you. Okay, let's try again. Oops, so go run. Alright, so my file is named buzz.go. Go run buzz.go. Okay, so it says that player 1 buzzes first, and then player 2 buzzes second. Let's try again. Now, it doesn't matter how many times I run this program, it will always be player 1 buzzing first, followed by player 2. And if you think back, that should make sense, because if you recall, by watching the lesson on channels, when I have on line 28 wanting to read from channel 1, if you recall, this is a blocking operation. So line 28 will not be executed until the go routine, this first go routine, actually writes to channel 1. And what's the consequence of that? The consequence is channel 2 will not be able to execute until line 28 gets executed. In other words, this is not what we wanted. Player 1 will always get the buzzer first, and player 2 will always get the buzzer second. And you can see that if I switch the channels. So if I say, let's wait for channel 2 and then channel 1, you'll notice that now player 2 is the one who always wins, right? Right? So even though we have 2 concurrent programs, and sometimes player 2 their go routine might finish first, and so they should buzz first. And other times, players 1 buzzer or go routine finishes first, and so they should buzz first. But the way we have it here, it's either player 2 always buzzing first or player 1 always buzzing first. And the reason is very simple, because when you read from a channel, it blocks. It's a blocking operation, which simply means that, so this blocks, okay? Which means that if it blocks, it will have to wait, line 28 will wait until something is written, in this case player 2, until something is written to channel 2. And only after something is written to channel 2 will this line unblock and execute, and by so doing it will allow the next line to wait for its go routine. Okay, we don't want this. This is not very good. Okay, so what your job is, or your task is to, well, we learned about, of course, obviously we learned about channels and we learned about go routines because we are using them. But we also learned about wait groups. We also learned about the select statement, and we also learned about mutexes. Okay, so your task is to go back over those concepts. All right, wait groups, mutexes, and select. And I want you to decide which of them we need to solve this problem. And once you decide which one we need to solve the problem, then I want you to implement the solution to make sure the problem works. And the way the problem works will be, when you run it, sometimes you will see player 1 buzzer coming first, and sometimes you will see players 2 buzzer coming first. Okay, so again, we do not want to always see that. We want it to be mixed up. Sometimes it's player 1 first, then player 2, and sometimes it's player 2, then player 1. Okay, because it should be random, because we are randomly sleeping. So there are times when this go routine finishes first, and there are other times when this second go routine finishes first, and so that should be reflected here. Okay, so again, look at wait groups, look at select, look at mutexes, and you must decide which one is needed to solve this problem that we have, which is one go routine. We're blocking, waiting for something to be written to the channel. Okay, and we don't want that. We want equal opportunity, where whichever go routine finishes first, we want to be able to read from that go routine's channel, or read from the channel that go routine wrote to. Okay, all right, so that's it. That's your assessment. I'll see you in the next lesson.